We're going to begin today with the first lesson in the unit on radicals. Radicals is the general term for roots or finding the root, square root, cube root, or whatever. We don't use the term square root only because square root just means we're finding what times itself is the result of a particular number. Radicals is the more general term where it can apply to any root. However, we're mainly going to deal with, in this unit, square roots. Now, what we want to do today, and it's the foundation of this unit, is simplifying radicals. Okay? Like anything, simplification means to break something down into its parts. All right? And think of it as almost like you're factoring. Now, just so you understand terms, radicand means the number under the radical sign. Radical is the radical symbol. Okay? Now, we're going to show you two methods to simplification. You only need to use one of the two methods, and it's whatever one you are comfortable with. Okay? Now, the first method, what we do, and I will demonstrate an example using each method, is we're going to find the largest perfect square that will divide evenly into the number under the radical sign. Again, our perfect squares, 1, 4, 9, 16, etc. Okay? Then write the number under the radical sign as the product of that perfect square and the answer that resulted from dividing. So in other words, we're going to factor the radicand into two parts. One is a perfect square, one is not. Okay, we're going to then find the square root of the perfect square, and that moves to the outside. The remaining number stays under the radical sign. If there are another number outside the radical sign, we will be multiplying. For variable exponents, the exponent has to be divisible by 2 to be a perfect square. If not, then we're going to break it into two parts, okay, with one part being a perfect square. And then we're going to make sure nothing under the radical sign is divisible by a perfect square. In other words, that we actually did simplify. Okay? Now, method 2 is we do a prime factorization of the number under the radical sign. If a prime number has a matching number, we're going to move one of them to the outside and eliminate the other one. If it doesn't have a partner, then it stays under the radical sign. We multiply numbers outside and inside, if any. Okay? For variable exponents, the exponent has to be divisible by 2 again to be a perfect square. Okay? And then make sure that nothing is factorable or divisible by a perfect square. So let's go through an example. We'll do the first one using both methods. So we have the square root of 48. Now, under the first method, we want to find the largest perfect square that divides into 48. That's 16. 16 times 3. Okay? I know 4 divides into it, but 4 is not the largest. All right? Now, if you think of this as the square root of 16 times the square root of 3, well, what's the square root of 16? It's 4. Radical 3. Straightforward. Simple as that. Okay? Now, the other method, the square root of 48, when I break it down into prime factorization, so I take 48, and let's do 8, 6, 2, 3, 4, 2, and 2, 2. It's 2 times 2, 2 times 2 times 3. Right? Well, the first two 2's have a partner, so one of them comes to the outside, the other one gets canceled. The other one has a partner, one comes to the outside, the other gets canceled, and 3 doesn't, and then I just multiply the 2. Okay? I'm going to use the first method because that's what I prefer to use. But again, you can use either of the two to simplify here. So radical 18 is 9 times 2, which is 3. Radical 2. Okay? So we keep going. It's orientation. Okay. 3 radical 175. And again, you just have to get comfortable with knowing your perfect squares. 25 times 7 which is 15 radical 7. 50x to the 6th, that's 25 times 2 times x to the 6th, which is 5x to the 3rd, the square root of 2. Now, how is it x to the 3rd? That's because x to the 6th is equal to x to the 3rd times x to the 3rd. Okay? As you remember from our unit on exponential functions. 3 radical 140 is 3 times 4 times 35, which is 6 radical 35. And again, the square root of 35, it looks like a pretty large number to still not have a perfect square, but the way you test it is 35 is 5 times 7. Those are both prime numbers, and that's as far as I can go. All right, 1/2. Okay, 72 is 36 times 2. Now we know x to the 5th is not a perfect square. So the largest perfect square that goes into x to the 5th is x to the 4th. It's the next lowest even number. So the square root of 36 is 6. 6 times 1/2 is 3. The square root of x to the 4th is x squared. And I'm left with 2x under the radical sign. Okay. And then to do the last two, x to the 3rd. 54 breaks down as 9 times 6. X squared is a perfect square. So this gives me 3x to the 4th. The square root of x squared is x times x cubed is x to the 4th. Square root of 6. And then lastly, negative 3. 9 times 3 times x to the 8th times x. Okay, which is negative 9. Square root of 9 is 3 times the negative 3 is the negative 9. Square root of x to the 8th is x to the 4th. And 3x is left under the radical sign. So again, what we covered today is simplifying radicals, and you can use either of the two methods to simplify. It is solely up to you as to what you want to do.